Exercise 4G, question number 12. Jose and Christina play darts on the same team. The events J and C are defined as follows. J is the event that Jose wins his match. C is the event that Christina wins her match. Probability that Jose wins is 0.6. Probability that Christina wins is 0.7. And probability of Jose and Christina winning J union C is 0.8. So let's draw a Venn diagram to represent this information. We have Jose winning and Christina winning. So this is the probability that Jose wins and this is the probability that Christina wins. J union C is 0.8, which means we know that the union of these two sets is 0.8. Therefore, J complement intersection C complement is going to be 0.2, which means outside both the sets is 0.2, as 0.8 is inside. Now, if we consider the intersection as X, now we can answer part A, which says find the probability that both Jose and Christina win their matches, which means we need to find X, which is the intersection of both the two sets. So if probability that Jose wins is 0.6, which means this entire circle is 0.6, then the probability that only Jose wins is 0.6 minus X. So let's write 0.6 minus X. Likewise, probability that Christina wins is 0.7. So the probability of this whole circle is 0.7. Therefore, the probability that only Christina wins is 0.7 minus X. So 0.7 minus X. It's given that J union C is 0.8. So let's set up an equation. Therefore, for part A, we have 0.6 minus X plus 0.7 minus X, and that equals 0.8. We can cancel out minus X and plus X, and 0.6 plus 0.7 is 1.3. 1.3 minus X is equal to 0.8. Therefore, X is equal to 1.3 minus 0.8, and X is equal to 0.5. So we have the probability of J intersection C as 0.5. So we can fill up the rest of the probabilities. This is 0.5. Therefore, this is 0.1 and this is 0.2. And we already have outside as 0.2. Now, let's answer for part B. Probability that Jose wins his match given that Christina loses hers. So if we want to find the probability of Jose winning given that Christina loses, so we have to look for everything outside C. This is everything outside C is the probability of Christina losing, and that is 0.1 plus 0.2, which is 0.3. That is probability that Christina loses. From this, we need to choose the probability of Jose winning. So it's going to be 0.1 divided by 0.3. So for part B, we have probability that Jose wins given that Christina loses. So Christina loses a C complement. That was equal to 0.1 divided by 0.3, and that is equal to 1 by 3. Third question is part C. Christina wins her match given that Jose wins his. So we want to find the probability that Christina wins given that Jose wins. So given that Jose wins means we are looking at only this part of the Venn diagram. From this, we need to find the probability that Christina wins over the total. So probability of Christina winning is 0.5 over the total, which is 0.6. So for part C, we had to find probability that Christina wins given that Joe's wins, that is equal to, once again, probability of Christina winning given that Joe's wins, that is equal to 0.5 divided by 0.6. So 0.5 divided by 0.6, and that is 5 by 6. And the last question is, determine whether or not the events J and C are independent. So in order to find out whether the events are independent, we need to find out whether probability of event J when multiplied by probability of event C, we need to find out whether or not this is equal to probability of event J intersection C. We already know that probability of J intersection C is 0.5. So this is 0.5. Let's find out what is probability of J intersection probability of C. So that is 0.6 multiplied by 0.7, and that is 0.42. That is not equal to 0.5. Therefore, events J and C are not independent. Not independent.